Welcome to Subtraction in Action. We're going to be exploring different methods that we can use to solve subtraction equations. Let's go ahead and get started. There are a couple of things to keep in mind. First of all, subtraction is related to addition in the same connection that multiplication is to division. The second thing that I'd like you to consider is we regroup in addition to solve a problem, but in subtraction, we ungroup to solve an equation. There are 4 methods that we're going to be looking at for solving equations. These will look somewhat similar to you from our addition video. Expanded form method, the ungroup first method, common US method, and proof drawing method. Again, I want you to keep in mind the connection between addition and subtraction. And let's go ahead and get started. The expanded form method. In our 4 methods, we're going to use the same equation, 134 subtract 58. So we will be kind of familiar with that equation at the conclusion of these 4 methods. So the first thing we do is we take 134 and 58 and we expand them to expanded form. So with 134 we have 100 plus 30 plus 4. With 58 we have 50 plus 8. Then we start with the ones, and there are not enough ones to subtract from 8 from 4. So take 10 ones from the 30 and give them to the 4 ones to make 14. Now let's look at the tens. Well, there are not enough tens to subtract 50 from 20. So we need to take 10 tens from 100 and give them to the 20 to make that 120. Now we have no hundreds, so we're going to subtract each place value. So 120 subtract 50 is 70, and 14 subtract 8 is 6. Now then we just add it together, we put it together. 70 plus 6 is 76. Now let's look at a different method. This is called ungroup first method. So in this process, we start and get everything ready to go before we even begin solving our equation. So we start with the hundreds, see if you have enough hundreds to subtract. We do. Then you look at the tens. So ungroup, because we don't have enough tens, we're going to have to ungroup the 100 to get us 10 tens. We give these new tens to the 3 tens to get 13 tens. Now there are not enough ones. We cannot subtract 8 from 4. So we ungroup one of the tens to get us 10 ones. We give these new 10 ones to the 14 ones, or the 4 ones, so that gives us 14 ones. Then we are ready to subtract. And what's wonderful about this is we can subtract in either direction. It's all ready to go. So 14 subtract 8 is 6, 12 subtract 5 is 7. Now this is what we call the common US method, and this method alternates ungrouping and subtracting. So let's go ahead and get started. We start with the ones, and there are not enough ones to subtract from, so we ungroup 110 to get 10 ones. We give these new ones to the 4 ones, and we end up with 14 ones. Now we subtract, we subtract. 14 subtract 8 is 6. Now we look at the tens. There are not enough tens So we ungroup the 100 to get 10 tens. We give these new tens to the two tens that we already have to get 12 tens. Then we subtract the tens. 12 subtract 5 is 7. Now if you look, the 0 is kind of whited out because there are no 100s now. So we have the answer 76. Now let's look at a proof drawing. Same equation we've been working on, and this proof drawing identifies in the same way that an addition method drawing uses, but we're going to be extracting numbers from them instead of adding. So we start out with our here is our 134 in a proof drawing, our 100 square, our box. Then we have our 3 tens, 10 sticks, and then we have our 4 circles, which represent 4 ones. Now, we are going to need to regroup in the same way. So we've taken away 10 from our 100 to give us 10 sticks, and we've put an X through that, identifying that it is no longer there. Okay, we now have regrouped, and we have enough now to subtract, but do we have enough ones? Well, again, we cannot subtract 8 from 4, so we're going to take one 10 stick and create 10 ones from that. Now we have enough to subtract. So we're going to take our 8 from our ones. We're going to take our 5 from our tens, and we will count what is left. We have 5 plus 2, that's 7 10 sticks, and we have 6 ones left, and that is 76. Can you see how simple the proof drawing works as we subtract from it? Now this is that tool that I demonstrated, but what is wonderful is the iTool can either be set up to subtract or add. So this one is set up to subtract. So we will be working with those iTools and exploring them. Now, one of the things that we start dealing with that can get a little scary, and I know people get a little bit worried about subtracting across zeros. So we're going to look at using a proof drawing to demonstrate the process and see how simple this can be. Now there are 3 questions you're going to ask yourself as you start subtracting. You're going to ask yourself, are there enough hundreds to subtract? Are there enough tens to subtract from? And are there enough ones to subtract from? If the answer to any of these questions is no, then we are going to have to regroup. So let's go ahead and look at how we would regroup. So our 3 questions, are there enough hundreds to subtract from? Well, yes, we have 5 hundreds, and our equation is 500 subtract 138, and of course we have enough hundreds. Yes, but then we look at the second question, are there enough tens to subtract from? Well, there are not. We cannot subtract 3 from 0. Are there enough ones to subtract from? Well, we can't subtract 8 from 0 either. So we are going to first start with our 5 100s boxes, and we've started with these. Then we knew that we're going to have to ungroup. So we've taken one of our 100 boxes and we've put an X through it, and we have created 10 sticks. Well, we don't have enough ones either, so we've put an X through one of our ones, or our 10 sticks, and we have created 10 ones. So now we are ready now to do some subtraction using this proof drawing. So we're going to take 8 of our ones, and I've just put a box around them. Then we're going to take 3 of our tens, and then we're going to subtract 1 of our 100 boxes. Now, if you simply just count what was left, we have 3 100 boxes, we have 6 10 sticks, and we have 2 ones. So the answer to our equation of 500 subtract 138 is 362. Now here is the same equation, and we have simply just used the common US method. We recognize that we do not have enough the ones column. We don't have enough in the tens column. So we have gone to the hundreds. We have taken 100 from, or 10 sticks from our 100, made this into a 4, changed this to 10, because now we have 10 there. But we have not got enough ones, so we are going to again regroup or ungroup, and we're going to take 1 10 stick and create 10 ones. So now we have 10 subtract 8 is 2, 9 subtract 3 is 6, and 4 subtract 1 is 3. Now, if you would like to pause this video and practice doing these two equations, subtracting across these zeros, you can use any of the methods that we demonstrated. You can go back and review those. We're going to move on and do a little practice ourselves. Practice does make us perfect. Now, you know, our puzzle penguin is always struggling. He has a hard time understanding these new concepts, I think. So he has done the equation 134 subtract 58. Now this is one that we practiced, and if you look at what his total is, it's most confusing. I've demonstrated over here the correct way of breaking down or ungrouping for this equation. And you can see what he did wrong. First of all, he tried to subtract, he just decided that he would subtract 4 from 8 instead of the 8 from the 4. And he well, I'm not sure what he did with the other. It looks like he subtracted again. We are going to simply correct him, and let's see what we learned from our friend Mr. Penguin. It says, no, you cannot subtract a larger number from a smaller one. The correct answer to Puzzle Penguin's equation is 76. Now let's look at one more problem. Now these are really fun because word problems become a real source of figuring out answers. So reading the instructions, it said solve the problem, show your work numerically and with a proof drawing. So we've got both here. It says the students at Olympia Elementary School collected 1,000 bottles for recycling. The students at Sterling Elementary collected 768 bottles. How many more bottles did the students at Olympia collect? So we've gone through the process of regrouping or ungrouping here, and we have come up with the answer of 232. Now we have also created a proof drawing, and you can see where we have ungrouped and created new groups of the ones and the tens, and we have 200 or 2 100s left. We have 3 tens left, and we have 2 ones. Let's see if we're right. 232 bottles. Very good. Okay. Now let's look at our last problem. It says there are 645 bicycles in a race. Toby finished 87th. How many bicycles finished after Toby? Now, the instructions simply say to solve. So we have ungrouped and ungrouped from the hundreds to the tens to the ones, and we've come up with the answer of 558 bicycles. Oh, we are right again. So, ladies and gentlemen, you can see that subtraction can be a simple process. It doesn't need to scare us. We need to practice and find the best method for each of us. Good luck, and we'll talk about this in class.